Hi everybody, what I would like to do with you in this video is show you how to graph a scatter plot, how to deal with this unique sort of graph, and differentiate regions of processes in that scatter plot. Now this is a really specific scatter plot that we're going to look at. It's called a Hillstrom curve. I don't want to spell that for you or show you what exactly it looks like right now. I want you to kind of do the hard work first, but that's what it's called, the Hillstrom curve. And we're going to learn how do these different processes work in terms of the size of the sediment and the speed of the water. Some of you have been coming up with questions about water speed and sediment, so this is going to address some of those questions. I'm also going to give you some tips on how to submit an assignment like this. The best thing to do in this case is to actually draw the graph by hand. Some of you have done an awesome job of creating graphs on the computer and sending those to me. That's wonderful. This one is a little bit more sophisticated, so it's rather difficult to do on the computer, although it is possible. I would suggest either print the graph and draw the graph by hand, or actually draw the graph space. So let me kind of show you what we're dealing with here. So this is the assignment. It's called Always Label Your Axes, Graphing River Processes. So there's a little pun here, if you notice. And I give you some instructions on the best ways to submit this. I'll talk about some of these. So there's a little reading here I want you to do. I show you some different sediment sizes. And sort of the big goal here is to be able to create and interpret a graph of how velocity and sediment are related. What do the sediment do based on different velocities? So here's some instructions that you can read at your leisure. There's a table of data. It's pretty complex. There's 40-something data points here. And then there's a graph space. And so between this data table and the graph space, this can be a little bit scary. There's a lot to do here, but I'm going to walk you through. Don't be scared. I'm sort of going to give you this little tutorial on how to deal with a graph like this. If we jump over here, so here's a single page where I've got some of the data on the table, not the whole thing, and then the graph. The first thing that I want to point out about this data table, look at what data we have. We have the diameter of the sediment, so different size particles. We also have velocity, so what velocity is the water moving at? And then over here, for action, what does a particle of that size do at that velocity? So we see that a particle with a sediment size of 0.001, this is in millimeters, if the water's moving at 9 centimeters a second, that particle is going to be transported. Over here, if we see here's a different particle at 0.05 millimeters, that particle at a velocity of 100 centimeters a second is going to be eroded. And still further over here, a sediment of diameter 0.1 at a speed of 0.5 is going to be deposited. DEP is short for deposited. So each of these rows shows a sediment, speed of the water, and what happens to the sediment at that speed. Okay, so that's the first thing to get straight on this table. I want you to familiarize yourself with these data, and they're all out of order. They're kind of roughly ordered by the diameter of the sediment, but everything else is out of order. So how do we deal with these axes? This is the first thing that's going to throw some of you off. So notice there's only a few dashes on these axes, and yet for both the diameter of the sediment and the velocity, they go all the way from 0.001 to really high numbers. You don't really see them in this particular sample, but some of them go up to like 100 millimeters or bigger. So we have a wide range of numbers to accommodate, and then for velocity, it's very easy to see in this video. The velocity, the smallest velocity in this data table goes all the way down to 0.1, and the highest one goes all the way up to 500. So there's a huge range of values that we have to demonstrate here. So I want to show you what these axes look like. I'm just going to go ahead and skip forward and kind of show you how do we resolve this issue. We have these huge ranges that we have to figure out. So if you look at your screen right now, notice that what I've done is let's start at the x-axis. For sediment diameter over here, it runs all the way from 0.001 up to, and like I said, we'll see there's some that get close to 100. So what I've done down here on the x-axis, instead of a linear scale, like 0.001, 0.002, 0.003, what I've done is what's called a logarithmic scale. So I'm starting at my smallest sediment size, 0.001, but then instead of just increasing in a linear scale, I've actually multiplied each dash by 10. So the decimal moves with each dash, 0.001, and then here, 0.01, then 0.1, then 1, then 10, then 100. You see what I've done there? Instead of just increasing by the same amount, I've actually multiplied it by 10. And then I did the same over here with velocity. We see our smallest velocity is 0.1, there we go, so that's my smallest velocity. And my highest velocity is 500, so let's end at 1,000. So 0.1, 1, 10, 100, 1,000. That's the first thing to get straight. That's why these axes look really kind of odd. But that also means this graph isn't quite going to work the same as a graph that you might be familiar with. So this is a lot of data to work with, and so there's our axes, there's some of our data. Something I would really suggest that you do is color code your data. So what I have done here, if you look at this table, I've now color coded erosion is in one color, it's green, transportation is in another color, it's pink, and then deposition is in still another color, and it's sort of a light blue, powder blue. So that's really going to help you keep your graph organized. I love color coding things. Some of you are natural color coders. I'm a color coder. And this really makes life a lot easier. If you before you do anything else, just color code all your numbers. Erosion should be one color, transportation another, and deposition still another color. So now that I've done that, I've kind of positioned myself really well to make an awesome graph over here and to start kind of differentiating these different regions of these processes. So let me kind of show you what we're going to see happening here. If I can zoom forward here. All right. So remember, our axes are a little bit strange. We have these funny multiplied by 10 axes. So if we do the first data point, we've got 0.001, that's the diameter, and that's on the x. So I've got 0.001, that's right here, and then my velocity is 9, and it's been transported. Now in my table, that's pink. So I've got 0.001, and I'm going to jump up to 9, and I'm going to put a dot right there. And might as well put a little check mark right by that data point, that way you know you did it. Now notice where I put that point. I've got 9. And that's somewhere between 1 and 10, and it's a little closer to 10 than 1. Well, quite a bit closer to 10. So that's why I put my point right there. Let's do this next one. So I've got 0.001, again, down here, my sediment size, 0.001. But my velocity is 300. So what I'm going to do is I'm going to put that point way up here, somewhere between 100 and 1,000, a little closer to 100. And there is my next data point, 0.001 at 300, right? That's how fast the water's moving, and this is the size of the particle, it's on the x. So if I keep moving forward here, kind of randomly, just doing a couple of these as we go. Here's the next one. The diameter of the sediment is 0.002, and so I'm going to make that a little bit bigger than 0.001. And then the velocity over here is 1, and so I'm going to set that at 1. So I'm not going to do all these, but I do kind of want to zip forward here a little bit. I'm kind of just doing some of these. Notice I'll actually go back and forth a few times. Notice that as I put each point on, I'm showing the check mark next to the row where I've done it. Okay, so I've got this this is a scatter plot, right? You should kind of recognize this. Let me actually jump backwards and do that again really quickly, just so you can kind of see how they populate. All right, ready? I'm going to go ahead and zoom forward, and I want you to watch where each one goes. Do you see how these points are populating the graph as I go through and I mark check marks next to the ones that I have done? Now, this I have done on the computer. I've actually positioned these little dots. This is just PowerPoint, and shown where each of these dots is. And you might be able to start to notice how the green, the erosion, all kind of happens up here. There's a blob of greens up here. This is only some of the data. This isn't all of our data. But once you graph it all, you'll see kind of a pattern emerge. There's some blobs of green up here. That means erosion is happening up here. Notice how this is all kind of high velocity. So that should sort of make sense, right? We talked about how high velocity means there's erosion going on. So that's what's going on up here. If the water's moving really quickly, we're going to have erosion, right? Green. And then if we look down here, this should kind of make sense too. So these blue dots, they might be a little hard to tell from the green, but these little blue dots here, notice that these blue dots are taking place at low velocities, 0.5 and 0.1. Well, that should make sense too, because we also saw that in rivers, if you have low velocity, those sediments tend to be deposited. And then, if you look at where the pink ones are, this transport, we see there's this kind of triangle shape forming, where transport happens the trend appears to be this. With small sediments, transportation happens at a low velocity, as we would expect. But as those sediments get a little bigger, it takes more and more speed, more velocity of the water to keep transporting those sediments. So do you see how we're kind of seeing a little bit of a trend emerge already? Once you go through, and if you color code, and if you go through and really carefully put all your scatter plots down, all your points, you'll start to see an even clearer picture emerge of this graph. So I want to show you now, because you've been so patient, I want to show you what this graph looks like, so that you can kind of get a sense for if you do your graph right, is it going to look this way? So we see that the particles are deposited down here. We're going to find this kind of sloping curve. This is all deposition. We're going to find this curve up here. This is all erosion, this sort of blobby looking thing. And then this funny yellow horn shape is transportation. And so if you do your graph right, it should look a little bit like this. It shouldn't look exactly like this, because our data is a little bit different than what you're going to get in here. It should look a little bit like this. And the whole point of this graph is you should be able to tell me, for a certain sediment size and for a certain velocity, what is the particle going to do? Okay, I can see here they're being moved along, they're being transported. I can see over here they're being dropped, they're being deposited. And I can see over here they're being eroded. So I hope that that is kind of helpful to see how to turn this table of data into an actual graph that you can make some meaning from. All you need to do in this assignment is just do the graph. Afterwards, I will start asking you some questions about it in a discussion format. The last thing I want to show you in this video is, how do you submit this? How are you supposed to submit this assignment? So once again, I really suggest that you draw your graph by hand. That is what I would really say you ought to do. Draw it by hand. Print it or draw it on a piece of paper. And then what you can do is either take a photograph of it and submit it on Schoology only, or you can scan it and submit it on Schoology. Please don't email me assignments, and please don't send them on Remind. I appreciate it if you do that, but you have to figure out how to submit it on Schoology, otherwise I lose track of them, and Schoology tells me that you're not active, even though you are. So I absolutely need you to figure this out, how to send this on Schoology. Most of you have figured it out already. So you can either take a photograph, or you can scan it and send it to me, upload it as an assignment on Schoology, or you can actually take a screenshot or save the file in a Word document and then send it on Schoology that way. I do want to show you how to do a screenshot, just in case you aren't sure how to do that. So suppose here you've made this graph electronically. You'll find on your keyboard, it's called PRTSCN, print screen. If you just press that button, and maybe on a Mac it's a little different, but if you press print screen, watch what happens. I'm going to paste. Look at what it did. It actually copied my screen. So now what I can do is I can actually save this, right click on it, save as picture, and I can save it as, assignment. Assignment 5. Save. And now when I go to upload that, where you click on submissions, you can just go ahead and you can upload that image, and I will see that. Alternatively, if you, let's say that you create it in a Word document and you jump over here to Schoology, same thing. Just click up here in submissions. I'm in the assignment, and actually I'll show you how to get here too. So suppose that here we are, we're in our page, right? All these assignments that we have. And if you go ahead and click on the assignment right here, just click on the blue, the name, the label. Up here, I know this looks a little different from what you'll see, but you're going to see a little thing that says submit. You're going to click on it, and that's what's going to let you choose your file and actually submit that. Like I said, you can submit an image, like a photograph or something that's scanned, or you can send me a screenshot or a file in a Word document. There's all kinds of ways that I will accept this, but you really have to use Schoology to do this. So I hope that this was at least a little bit helpful in figuring out how to put a scatterplot together, especially with this remote learning that we're doing, and how to tell these regions apart. And I hope that that also helps you get a little bit of an insight on how do you send something like this to me on Schoology. Remember, the only assignment is just to do the graph and send it. That's it. Later we're going to do some other work. So again, I hope this is helpful, and I invite you to reach out to me if you have any concerns or questions about anything.